For finding the negative of a number, we have to use from the complement of the number. It means that if we could find a complement of a number, means that in the binary systems, we can find the negative of this number. Generally, we have two different types of the complement for each R-based systems. One of them is called as radix complement, as you can see here, the radix complement, or called as R's complement. Another type of the complement is diminished radix complement, which is equal to R minus 1's complement. What are these two and how we can find these complements? I want to explain to you. First of all, suppose that we want to talk about the diminished radix complement or the R minus 1 complement. The general formula for finding the diminished radix complement is this: R to the power of n minus 1. So I want to show you that how we can find it. Look at here. For calculating or finding the radix complement or I minus 1's complements, suppose that first of all we are talking about the R is equal to 10. So R minus 1 will be equal to 9's complement. In the decimal system, the 9's complement found using this general formula: R to the power of n minus 1 minus n. This n is our original number. This R is the base, and this lowercase n is number of digits of n, this original number. So as an example, suppose that n is equal to this one. Okay, now I want to find the 9's complement of this n. How can I do that? So what is the n, the lowercase n? 1, 2, 3, 4, 5, 6. Now if I substitute to the formula, R is 10, 10 to the power of 6 minus 1 minus 6. So if you look at here, and if you calculate this one, we have 1, 2, 3, 4, 5, 6 minus 1. If you calculate this subtraction, you will have 1, 2, 3, 4, 5, 6, 9 minus this one. So if you do this subtraction, you can find the 9 complements of the number as generally I can say that according to the number of the lowercase n, write the 9's. You can find this, the value of these parentheses, 9, 9, 9, 9, n times. Then subtract with the original number. You can find the 2's complement, 9's complement. What about the actually 2's binary number? So if we suppose that R is equal to 2, the R minus 1 complement is 1's complement. I want to find the 1's complement of a binary number. So the formula is the same, r to the power of n minus 1 minus n. So if I suppose that n is equal to 1, 0, 1, 1, 0, 0, 0, want to find the ones complement of this number. Again, according to this formula, 2, because r is equal to 2. What is the lowercase n here? 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7 minus 1 minus 1, 0, 1, 1, 0, 0, 0. So again, if you find this one, you will have something like that. 1, 1, 2, 3, 4, 5, 6, 7 minus 1. You will have 1, 2, 3, 4, 5, 6, 7, 1. And again, you have to subtract this one by the original number. And if you subtract these two numbers with together, you can get this one, 0, 1, 0, 0, 1, 1, 1. If you write this one under this number, you can find that. So this is my original number, n, and this is the ones complement of n. Now, if you look at to these two numbers, you can say that all of the zeros converted to 1 and all of the ones converted to 0. What does it mean? It means that instead of using this formula for finding the ones complement of a binary number, you can use from this tricky way. If you have a number, for example, 1, 0, 1, 1, 1, 0, 0, 1, the ones complement of this number is equal to 0, 1, 0, 0, 0, 1, 1, 0. That's it. So I can say that according to this concept, the ones complement of a binary number is formed by changing ones to zeros and zeros to ones, like these examples that you can see here. That was the first complement of a binary number. Now, what about the radix complement or 2's complement in the case of the binary numbers? The general formula here is in the 2's complement or r's complement is this, r to the power of n minus n. So if I write this formula in this form, to the r's complement is equal to r to the power of n minus n. So I can rewrite this formula in this form, r to the power of n minus 1 minus n plus 1. This one removed by this one, at the end I will have this one. So if you look at to this section of formula, this is the r minus 1's complement plus 1. What is this? This is the r's complement. What's happening? We say that for finding the r's complement, take the r minus 1's complement, add with 1. If r is equal to 2, I can say that 2's complement of a number is equal to first complement plus 1. And we have learned that how we can find the first complement. For example, suppose that n is equal to 101101 and says that find 2's complement of n. I say that because I know that first complement of this number is 0, 1, 0, 0, 1, 0. If I add 1, I can find 2's complement. 0 plus 1, 1, 1, 0, 0, 1, 0. Now this is the 2's complement of n, and this is the first complement of n. With adding by 1, I can find the 2's complement. Now look at these examples. These are the examples in the case of the 9, so we don't consider it. The important thing is that we want to find the 2's complement of the numbers in the binary systems. So for example, look at here. This is the 2's complement of this one, and this is the 2's complement of this one. Again, I want to show you that we have another tricky way for finding the complement, 2's complement of a number. If you look at, this is my original number, okay? This is my original number. And 2's complement of the number is this. If you compare this number with the original number, you can say that all of the zeros from the LSB, from the right side, all of the zeros are the same. And the first one also is the same, will be constant. Then the rest will be converted. 1 converted to 0, 0 converted to 1, 1 converted to 0, 1 converted to 0. That's it. So the 2's complement of the first number is obtained by the leaving 2 least significant zeros and the first one unchanged, then replacing ones with zeros and zeros with 1. For all of the other numbers, we can apply this process. So here we don't have any 0 in the right side, but unchange the first one, then you can see that replace 1 by 0, 1 by 0, 0 by 1 up to the end. And this is the way of finding the 2's complement of the numbers. So why we use this, why we learn these two concepts? Because we want to show you that when I want to write the negative of a number, I have to take the first complement or 2's complement. And using this concept, I can do subtraction. I can do subtraction. And here also I explain how we can find the radix. Now, how we can use the complement for in the case of the subtraction. We say that the subtraction of two n-digit unsigned numbers, in this case, in the base of R, can be done in this form. We say that we add the min and m to the R's complement of the subtrahend n. What does it mean? It means that we find the R's complement of this n. Then mathematically we can write something like that. Now, if n is greater than n, sum will produce the carry. So we discard this carry and the left is our result. So it doesn't matter. We don't need to investigate the m is greater than n or not. Generally, in the case of the 2's complement, if I want to talk about the binary numbers, here I want to find actually the subtraction using 2's complement. I say that first of all, find the 2's complement of the n, then add by m. If the result has carry, discard the carry, the rest is the result. If we don't have the carry in the result, find the again r's complement of the result and place a negative sign in front. Look at this example. This is the tens complement but we don't want to consider the tens complement. We want to consider the binary numbers. So in this example, the two binary numbers x and y is given. We want to subtract x by x minus 1 and y minus x using 2's complement. So in this case, we say that because we have in the case of a x minus y, x is minuend, y is subtrahend. According to the procedure, we have to find 2's complement of the subtrahend, which is equal to y. Y is this. What is the 2's complement? The first one is unchanged. The rest will be replaced. Unchanged, 0 get 1 get 0, 0 get 1, 0 get 1, 1, 1 up to the end. Now set that add these two numbers with together. Add x by 2's complement of y. I add it. When you add it, you can see that the x and y have 1, 2, 3, 4, 5, 6, 7 bits. But the result, the summation, has 1, 2, 3, 4, 5, 6, 7, 8. It means that we have carry. Discard this carry. Remove this carry. So the rest is the result. 0, 0, 1, 0, 0, 0, 1. The answer of the x minus y is this. Discard the carry, the rest is this. Now, what about the y minus x? In the case of the y minus x, now this time x our subtrahend. It means that I have to take the 2's complement of x for doing this subtraction. Okay, let's do it. 2's complement of subtraction of the x according to this number is 0, 0, 1, 1, 0, 1, 0. 0, 0, 1, 1, 0, 1, 0. Now, if we add these two numbers with together, we can get these numbers. So, if you look at here, in this result, in this summation, we don't have any carry. If we don't have carry, the procedure, the method says that, again takes 2's complement of this one. Take 2's complement of the result, this is, and place the one negative here. What is the 2's complement of this one? The 1 is constant. 0, 0, 0, 1, 0, 0. Look at here, and this is the result. So using this method, the 2's complement, we can do subtraction. Okay. We have another method for doing these subtractions using r minus 1's complement. In this case, the same procedure happens, but if in the addition, after taking the r minus 1 complement, the procedure starts with the taking r minus 1 complement of the subtrahend, then add the minuend by the 1's complement or r minus 1 complements of the subtrahend. If the result, in the result we have carry, discard again this carry and add by 1, then the result will be our subtraction. If the result don't have carry, then again take the r minus 1 complement and place the actually negative. Now look at here, using one example, I want to explain it. Again, I want to do the same x and y and subtract the x and y and x with together using the first complement this time. We say that because I want to have x minus 1, I have to take the first complement of the y. The first complement of y is 0, 0, 1, 1, 1, 1, 0. Add these two numbers with together. So you can see that I have the carry. We discard this carry, remove it, then add by 1. Now if I add by 1, the result is equal to this one. Now if I have y minus x, in the case of y minus x, I have to take the first complement of x. The first complement of x is the 1, 1, 0, 1, 0, 1, 0. Look at here, this is the x. Add these two numbers with together, I can get this one. You can see that here I don't have carry. When I don't have carry, means that I need to again find the first complement of the number. The first complement of the number in this form, and place this negative sign here. What is the first complement of this number? 1, 0, 0, 0, 1, 0, 0 with the negative. So you can see that it doesn't matter we use the 2's complement or 1's complement in the subtraction, the result are the same. But in the 1's complement, we have to add 1, 1. And when we want to do the complement, we have to do the first complement instead of 2 complement. That was the subtraction with the complements.